So electromagnetic interference, shortly called as EMI, and it is also called as radio frequency interference. So which is occurred in a frequency spectrum, radio frequency spectrum. So which is nothing but the disturbance signal, which is nothing but the disturbance signal, okay, which affects the circuit, which affects the testing circuit, or which affects the processing system by electromagnetic induction, electrostatic coupling, or conduction. Okay, this refers to nothing but electromagnetic interference. So an electromagnetic interference is nothing but a radio frequency interference. So when in radio frequency spectrum is a disturbance generated by an external source that affects an electrical circuit by electromagnetic induction, electrostatic coupling, or conduction. So with this electromagnetic interference, there will be a degrade in the performance of the circuit, and eventually it stops functioning the a particular system. It stops functioning the a particular system. So that means interference is nothing but a disturbed signal or disturbances caused to the original signal or along with the original signal, okay, which affects the electrical circuit either by electromagnetic induction, electrostatic coupling, or conduction. So with this electromagnetic interference, so there will be degrade in the performance of the circuit, and eventually it may stop functioning. Okay, so that means that, so EMI is the one so which is caused by one electric or electronic device to another electric or electronic device by the electromagnetic fields, by the electromagnetic field set up by the system. So that means that, for example, take a transformer, you have take the second transformer, and the first transformer will have some magnetic field. So because of that magnetic field, what will happen, there will be a effect on the second transformer, there will be a effect on second transformer. Okay, so this effect is due to that of the interference, that is caused by the first transformer. Okay, so similarly there will be an impact on the first transformer also by the second one. So that means that one electrical device to another electrical device, so which is caused by the electromagnetic fields, it refer to nothing but the interference. So that is referred to the electromagnetic interference. So this interference may arise from many sources, either it may be by man-made or it may be natural. It may be a man-made or it may be a natural. So, and also it has very variety of characteristics and depending upon its source and nature of mechanism. So depending upon source means whether this interference is subjected to a man-made thing. So for man-made thing imply nothing but any oscillator which produces a signal. Okay, so because of the signal also there may be some interference, or natural. Natural implies nothing but the lightning thunder. The lightning thunders. We have some lightning thunder. Those are nothing but the natural things. So which are occur during rainy season. Lightning of thunder. So though for that one also there will be a interference. Disturbance will cause for that one. And similarly a cosmic energy. The cosmic energy from the sky. So those are also nothing but the one of the interference that is caused by the nature. Okay, and the nature of mechanism. So what type of principle that are used in controlling the system, controlling the equipment or controlling the device. Okay, so based upon that also the electromagnetic interference may arise. Okay, so simply say that electromagnetic interference is a unwanted signal at the receiver. It is a unwanted signal at the receiver. Okay, so unwanted signal means the receiver is supposed to receive one particular band of frequency, particular band of signal. So along with particular band of signal, there will be some unwanted signal also. So this unwanted signal may disturb the actual performance of the system. Okay, so the main thing is that we have to reduce this unwanted signal. That means that we have to reduce the level of interference. So that refers to nothing but EMI, that is electromagnetic interference. For example, if somebody is making something, so the other person will go and interrupt him. So that what will happen? The performance of the person who is doing the work will be altered, okay, or degraded. So in order to have more performance, so that's what we have to omit the unwanted person. So which it doesn't use in any of the case. Okay, in that manner, so the unwanted person is nothing but the unwanted signal here. Okay, so EMI is nothing but a unwanted signal, so which is there at the receiver. So in order to improve the performance of a system, we have to reduce this unwanted signal, which is also referred to as interference. Okay, so coming to the type of interference. So the electromagnetic interference may be of many ways from many sources. It may be of many ways from many sources. So let us categorize it based upon the different things. Let us categorize the same based upon the different things. So the one way is nothing but by the way it was created. By the way it was created, either by man-made or by natural occurring EMI. By man-made imply nothing but, so this EMI arises from a electronic circuits and electronic circuits. So which affect the other circuits, which affects the other circuits, and this may be occurred either from switching of large currents, either from switching of large current. That is, for example, take you are you are switching the power grid on. You are switching the power grid on. So whenever a power grid on implemented, there will be a lot of things that is under the power grid. That means that there is a lot of industries, and there will be a lot of things, a lot of houses, everything will be there. So everything will be under this power grid down. That means whenever switch on the power grid implement, there will be lots of current that will be flowing on immediately. So at that time the electromagnetic interference may occur. So that is the thing, that is switching of large currents. Switching of large current, for example, in industry. So when you switch on the main, what will happen? Immediately all the machines is supposed to be take that current, okay, in order to run. So similarly, that case nothing about the man-made interference. So when you switch off large current, what will happen? There will be immediate flow of current. So when there is a flow of current, automatically there will be a field. There will be a magnetic field will occur, and this magnetic field will obstructs will have some impact on the other devices which is nearby. Impact on the other devices which is nearby. So that refers to nothing but the man-made interference. And next one is natural occurring EMI. So natural occurring EMI which is occurred by nature, like cosmic noise which is from the sky, and as well as lightning. So lightning is nothing but that is thunders. Okay, lightning thunders. So then when we get in the rainy season, so those are also nothing but occurring EMI. That means whenever the light process imply nothing but the because of the flow of current in the light rays. So what will happen? A field will be occurred. So this field will also affect the system in many ways, like that atmospheric type noise. So all these contribute nothing but the natural occurring EMI. Okay. So one way is nothing but the way it was created. It may be a man-made or it may be a natural occurring one. Next one is by its duration. How much time? How much time the interference will be there? How much time the interference will be there? So like that. So in that one we have continuous interference and impulse interference or impulse noise. Continuous interference. So continuous interference means a continuous signal which is generated by oscillator. So whenever a signal is generated by the oscillator, there will be a continuous waveform. Okay, so because of continuous waveform, what will happen? There will be an interference also. Okay, that is the continuous interference, or it may be from wide band noise. It is in the form of wide band noise as well. It may be in the form of wide band noise. Okay, sometimes this continuous interference also occur in the as the background noise, where it may be created by man-made or natural occurring one. It may be created by a man-made or natural occurring one. So that refers to nothing but continuous interference. Next one is impulse noise. So this may be again by man-made or natural occurring one. So but the thing is that it will come like a pulse, start pulse. Immediately it will come and go. Immediately it will come and go. That refers to nothing but impulse noise or impulse interference. So it consists of a short pulse, short impulse. So like lightning. So how the light will come, the thunder, it will come and go. That's all. So it is nothing but an instant one, a quick one. So immediately a pulse will appear and it will be close off. In the similar manner, so it may be arise from a electrostatic discharge. So electrostatic discharge imply nothing but the immediate discharge of the some current to that of the ground. That is nothing but electrostatic discharge. And for example, if you rub the plastic, so what will happens? There will be some a field will produces. So whenever you put that one, when you put that one in some of the papers, automatically there will be a discharge that will takes place. So that is nothing but electrostatic discharge. Immediately it works. So that means that whenever the body itself will have some charge, the body itself will have some charge. Okay. So without discharge your charge, if you uh, go and touch any of the PCB boards, so which consists of many ICs, etc. So what will happen? So when you touch that IC implies what will happen? That IC will burn off. That IC will burn off. That is nothing but discharge. That is electrostatic discharge, which is there in our body. So before going to touch that circuit, we have to discharge ourselves. We have to discharge ourselves. That means we have to remove our shoes or chappals, and then we have to make it ground, and then only we can touch that board. Otherwise, what will happen? Immediately the board will gone. That may be the one of the case of electrostatic discharge. It is which is discharged immediately, and when the circuit is switched on, when a circuit is being switched on. So immediately when you switch on the any switch implement, what will happen? There will be spark will come. There will be a spark will come. So immediately what will happen? There will blinking will a blink will there. So that also refers to nothing but the impulse noise. So by its duration. So it is characterized by its duration, that is continuous interference and impulse interference. So that is the other one, and the next one is nothing but by their bandwidth. By their bandwidth. So it has narrow band and broadband. It may be narrow band and broadband. So narrow band implies nothing but it is a carrier source signal, okay, which is generated from an oscillator. Which is generated from an oscillator. Narrow band signal which is generated from an oscillator. So whenever there is a single carrier source, it will have some spurious signals. The spurious signals is the one which is caused due to the intermodulation and the other forms of distortion in the transmitter. Okay, for example, such as the mobile phone of Wi-Fi router, such as a mobile phone of Wi-Fi router. That means that these spurious signals will appear at different points in the same spectrum and may cause interference to the another person who is using the same spectrum, and may cause interference who is using the another spectrum. So those are nothing but the spurious signals. The spurious signals will be caused by the oscillator which is generated a signal, and these signals will appear at different points in the same spectrum, and when it appears at the different point in the same spectrum, it will interference the other person who is using the same radio spectrum. Okay, that is nothing but the spurious signal, and this spurious signal is referred to nothing but an interference, and it is caused and it is likely to be in the narrow band. It is likely to be in the narrow band. Okay, that is the one. And coming to the broadband, it is also have variety of sources. So one of the man-made broadband interference can be arise from the sources like arc welders. Arc welders, where there is a spark continuously generated. Where there is a spark continuously generated. That is a broadband interference. That is a broadband interference. The other interference is nothing but a natural occurring broadband noise. So which is experienced from the sun. Which is experienced from the sun. So it causes sun outs for satellite television system. So what is sun outs imply nothing but, so when the sun appears behind the satellite and the noise can mask the wanted satellite signal. and the noise can mask the wanted satellite signal. That means that whenever the sun is behind the satellite, whenever the sun is behind the satellite, so what will happen? The noise can mask the wanted satellite signal. So that means until unless the sun is behind the satellite and the rays of the sun is also falling on the satellite and it is parallel to that of the wanted signal itself, okay, which is reaching the ground station. So at the time what will happen? There will be a parallel signals, so which is parallel to that of uh, the satellite signal and the sun's rays. Okay, these two signals are parallel. So anyway, the sun's rays will have a interference signal, and the satellite signal will also have some interference. So both interference will bombarded together, and there will be a loss of signal. There will be a loss of signal. So and this will be there at a particular moment only. That is when the sun is behind the satellite. So after some time, what will happen? The sun will crosses the satellite, and therefore we'll get the we will get the original satellite signal. Okay, so that is nothing but the sun outs. That is nothing but the sun outs. So here the types of EMI is by their bandwidth, that is narrow band and broadband. So that is about the categorization. Now based upon the coupling mechanism also. Based upon the coupling mechanisms also, so we have the interference. So we have the coupling mechanism of three types. One is radiated, another one is coupled, another one is conduction. Radiated, coupled, and conduction. So we have three types of coupling mechanisms. Either we can place the emitter and the susceptible equipment. So susceptible equipment is nothing but, for example, take the receiver. Equipment is nothing but a receiver, and emitter must be a transmitter. Okay, from transmitter to receiver, we should have certain gap. There is a certain gap, and that gap is somewhat greater than that of a wavelength. If the gap is greater than that of a wavelength, okay, so that means that the transmitter is one which radiates the energy. That means that it may radiate the wanted signal or it may be radiated the unwanted signal also. And the equipment is nothing but a receiver which may receive the both type of signals. So when it receives a both type of signals imply nothing but, so what will happen? There will be a degrade in the performance of the receiver. So that means that there will be some malfunctioning in the receiver. So for that one, what we have to do? We have to eliminate that interference. That means we have to reduce that level of interference so that the equipment will work satisfactorily. So that is the first one, that is radiated. So that is radiated imply nothing but the source and the victim are separated by a large distance, typically more than a wavelength. So the source radiates a signal which may be wanted or unwanted, and the victim imply nothing but the receiver side receives the signal and it may disturbs the performance. It may disturbs the performance. So to overcome this one, what we have to do? We have to reduce the interference. We have to reduce the level of interference. So that is the first one, radiated. Next one is conductor. So conductor imply nothing but the third one, that is conduction. That means there is a direct path between the source and the victim. There will be a direct path between the source and the victim, either by power cables or it may be some twisted cables. So whatever may be. That means that there will be a direct connection between the source and the destination. That is conduction. So during conduction, what will happen? There may be also some interference. There may be also some interference. That is, so conductor emission occurs when there is a conduction route along which the signals can travel. That is, there is a connection between the source and the destination. It may be a power cables or any other intercabling system. Any other intercabling system. And this connection may be of two modes. One is common mode, another one is differential mode. So common mode implies nothing but the type of EMI coupling occurs when noise appears in the same phase on the two conductors. When noise appears in the same phase on the two conductors. For example, So this is the conduction. If there is another line also, what will happen? We have two lines. So in the two lines, the phase is same. For the two lines, the phase of noise is same. The phase of noise is same, and that is why it is called as common mode. That is, it is called as common mode. Common mode. And coming to the differential mode, the noise is of different phase. The noise is of different phase. So therefore, it is referred to nothing but the differential mode. Therefore, it refers to nothing but differential mode. So in order to overcome that one, we'll have some twisted cables. Twisted cable, that is two wires will mingle up each other. That is twisted cables. So for that one, we can use that twisted cable means there will be some reduced in the interference. So that is the other case. And next one is the coupling type. The coupling. So here we have coupling is two couplings, either capacitive coupling or magnetic coupling, otherwise called as inductive coupling. Capacitor coupling or inductive coupling. So capacitor coupling means nothing but the charge is transferable here. The charge is transferable via a coupling mechanism called capacitive coupling, whereas inductance, so varying magnetic field will produce a current, and that current is transferred here, and that current is transferred in the equipment, that is to the victim. So this refers to nothing but the interference. So here the couple, in the couple one we have two forms. One is capacitive coupling and magnetic coupling, that is nothing magnetic induction coupling. Okay, in capacitive coupling, so occurs when a changing voltage from source capacitively transfers a charge to the victim. A changing voltage from the source capacitively transfers a charge to the victim. Similarly, the magnetic coupling implies nothing but varying magnetic field exists between the source and victim, and therefore it induces a current and it transfers the same current to the victim. It transfers the same current to the victim. So that is nothing but the magnetic coupling. So these are the different types of EMIs where we come across. So therefore, in all the cases, in all areas, there will be some interference. In all the cases, in all the areas, we have some interference. So by understanding the source implies nothing but how the interference has been generated. Okay, by understanding the source and the methods of the susceptibility of the victim and the methods of the susceptibility of the victim, we can reduce the level of interference. We can reduce the level of interference, and thereby the performance may increases, and thereby the performance of the system may increase. So that refers to nothing but EMI, electromagnetic interference. So interference basically itself is nothing but a unwanted signal, and the unwanted signal is produced by the different sources. Okay, and due to this unwanted signal, what will happen? There will be some degrade in the performance of the second system when compared to that of the first system. Okay, that is first system electromagnetic interference will degrade the performance of the second system like that. That is nothing but the electromagnetic interference. So coming back to electromagnetic interference, so electromagnetic interference may be of two types, either by man-made or it may be natural. So based upon the types of interference, we have man-made and natural occurring one by the created, and second one is by its duration, whether it is continuous interference or impulse noise or impulse interference. And third one is either by bandwidth, that is narrow bandwidth or broadband, and by coupling mechanism, that is radiated, conduction and couple type. So we have three types of mechanisms, and therefore in all the cases there will be interference. So unless until we reduce the interference, the performance of system will not improve. So that is about the EMI. And next comes to EMC. So what is EMC? EMC is nothing but electromagnetic compatibility. EMC is nothing but electromagnetic compatibility. So electromagnetic compatibility implies nothing but it is the concept of enabling different electronic devices. It is the concept of enabling different electronic devices to operate without mutual interference. Operate without mutual interference. So mutual interference implies nothing but, for example, the same case, two transformers, when kept aside, so what will happen? The field, the electric field of one is impact on the other one. Okay, that is nothing but the mutual interference. So which are also called as electromagnetic interference. So when these are operated very close to each other, when these are operated very close to each other, that means that in order to overcome this one, the two transformers has to kept at some distance, which in which the electromagnetic interference will not affect the other system to the other system. So that is a possible way. So electromagnetic compatibility implies nothing but it is a concept in which the electronic devices has to operate so without the influence of the interference, omitting the interference, otherwise called as omitting the interference. That is, the interference effect should not impact on the a particular system which is operating. So that refers to nothing but electromagnetic compatibility. So now, so we know that all the electronic circuits have the possibility of radiating and picking up unwanted electrical signal. That is nothing but interference. So sometimes what will happen? So when you pick up this interference, some circuits may have the performance at the same performance, or some circuit may be degraded by the performance. So that means that it accepts all the things, and therefore EMI is defined in such a way that it is the ability of the devices and systems to operate in their electromagnetic environment without impairing their functions, without degrading their functions, and without faults. So this refers to nothing but the EMC. EMC is nothing but electromagnetic compatibility. For example, you people are third year people. So you are eligibility for writing the GATE exam. Okay, that is you have a compatibility in writing the GATE exam. That means that you people know almost all the subjects, almost all the basic subjects you know. So that means that you are compatible in writing the GATE exam like that. That means electromagnetic compatibility is the one. It is the ability of the devices and systems to operate in the electromagnetic environment, without degrading their performance, that is without faults. Is nothing but EMC. That means that EMC ensures that the system can operate in the electromagnetic environment, in an electromagnetic environment in which in which in which the system performance cannot degrade. That is electromagnetic compatibility. So coming to the next point. So the main aim of the EMC is nothing but it measures the variety of different types of electronic equipment which can operate, which can operate, which can operate or which can performs well, even though there is an interference. It measures how capability of the equipment when it is operated in the interference condition. So that is nothing but EMC. So you know that the interference is nothing but which gives rise to some degrade in the performance, and we have to reduce that interference in order to increase the performance of the test equipment from one to the another. So we have two main elements in the EMC. One is the emissions and one is the susceptibility and immunity. One is emission and other one is susceptibility and immunity. So we have two main elements in EMI, EMC. So emissions are nothing but the interference. Okay, so these interference should be within the limits, within the acceptable limits, within the acceptable limits, and therefore it does not cause any disruption in the equipment. It does not cause any disruption in the equipment. For example, take the signals from the telephone company. So the signals from the telecom company should not go beyond this radiation, should not go beyond this radiation. So if you go beyond this radiation, there will be some impact on the people. So that is nothing but EMC measures. That is nothing but the electromagnetic compatibility. So the system has to work within the limit only, within the limit only. So similarly, the emission should also within the limit only. So that means it should not emission beyond that range. So that is all covered by the electromagnetic compatibility. The next one is susceptibility or immunity. So that means that it is a point in the electronics in which it reacts to the unwanted signal. In which it reacts to the unwanted signal. The unwanted signal is nothing but the electromagnetic energy. So therefore, the circuit is designed in such a way that it should have high level of immunity. It should have high level of immunity such that even though there is unwanted signals, even though there is unwanted signals, there should not be any degrade in the performance. So that is the two elements of EMC, that is emission and the immunity. So coming to the EMC standards, so that is every system will have some different standards. So it is nothing but the awareness and maintain high standards of electromagnetic compatibility. It is the awareness, that is the awareness has to be increased further in order to maintain the standards of electromagnetic compatibility. So many standards have been introduced to help the manufacturer to meet the levels so that to maintain full electromagnetic compatibility. For example, that is what you get is ISO 2001 2017 standards. It will be like that, no? So for particular thing, these standards has to be followed. These standards has to be followed. So that is also come under EMC in case of electromagnetic conditions, radiations. So therefore, it is very necessary to introduce EMC standards for every people, to ensure required levels of compatibility. So that means that EMC will be an integral part of any electronic design project. EMC will be an integral part of any electron design project. That means without EMC standards, we cannot design a project. That is the thing. So if a project has been designed, it has to be tested as per the EMC standards. Whenever a product has been released in management, it has to test with relevant to that of the EMC standards. So that means that if the standards are not met, means the system has a failure system. That is, it will produces a lot of errors. So because of that, we have the test has to be passed. The system has to be passed. That is, a design project has to be passed by the EMC standards. We have different EMC standards for different things. For example, for aeronauticals, we have different EMC standards. For example, for different different communications, for signal transferring, we have some different standards. We have to pass these standards for particular thing. So therefore, so in order to meet that one, the EMC practices have been employed, and therefore the project performance has been increases in order to operate on all reasonable scenarios. In order to operate in all reasonable scenarios. So that is nothing but the EMI standards. So where we can address these EMC standards. So in the preparation of circuit design for minimum radiation, we can use EMC filters, electromagnetic and interference filters. While partitioning the circuits, we can follow the standards. And grounding, that means that each and every system has to be ground properly in order to not expose the interference. And screen enclosure, it is closed by a protective coating or protective box like that, and screen lines and cables. So that is all the cables has to be covered with some protection. So like that. So that is about the EMC areas where you can go. And so therefore, by adopting this all the precautions, we can make the system of the performance will be very high. Okay, similarly, if unit has to be successful imply nothing but it has to provide high level of electromagnetic compatibility, and therefore the performance will be increases, and there will be reduction of EMI. EMI is interference. So that calls about the EMI and EMC. Okay, and tomorrow we will see next class we will see about the overall view of the thing. So that is EMI and EMC. So EMI nothing but interference, and EMC nothing but compatibility, in which a device can work within the interference range. So that is nothing but EMI and EMC.